Question number 19. The figure below shows a metallic block with a uniform cross-section. Calculate its volume. Now, when you look at this metallic block, it is made up of two shapes. There is the rectangular part, and then there is the top part, which is in the shape of a wedge. So we're going to get the volume of the rectangular part, and then we add the volume of the upper part, which is a wedge. So the volume of the rectangular part is given by the length times the width times the height. So we shall have 6 centimeters by 10 centimeters by 5 centimeters, and this will give these 300 centimeters cubed. That is the rectangular part. Then we have the top part, which is a wedge, and for a wedge, to get the volume of that wedge will be given by the area of the cross section, multiplied by the length. The cross section is a triangle that measures 4 centimeters by 4, and then this side is 6 centimeters. So how do we get the area of that triangle measuring 4 centimeters by 4 centimeters by 6 centimeters? By simply using the Hero's formula. So we have 6, we have 4, we have 4. So we're going to use the Hero's formula. So, and the Hero's formula is given by S minus A, S minus B, S minus C. Then you get the square root, where we get S by adding the measurements, the 3 measurements, and then we divide by 2. 4 plus 4 plus 6, and then we divide by 2, which will give, this will be 14 divided by 2. So S is 7. So therefore, the area will be given by S, which is 7. Then 7 minus the first measurement, A, will be 6. So this is equivalent to A. This one is B. This one is C. So subtract 6. 7 subtract 3. Subtract 4. I mean, this is 4. Then 7 subtract 4. We get the square root of that. This will give 7 multiplied by 1 times 3 times 3. This will give the square root of 63. So that is the area of the cross section. Therefore, now we can get the volume. So volume is given by, now, of the wedge, the area of the cross section, which is the root of 63 multiplied by the length. The length will be 10 centimeters. So multiply by 10 centimeters. So the root of 63, can get the root of 63, which is 7.9. This 7.9, using a calculator, 7.937. So multiply by 10, this will be 79.37 centimeters cubed. Now we can get the total volume, the volume of the rectangular part. So total volume is given by the rectangular part, which we got as 300 centimeters cubed, and then we add the wedge, which is 79.37 centimeters cubed. So we get the volume as 379.37 centimeters cubed. So that is the volume of this metallic block. Now let's go to the surface area. Now its surface area, the surface area. So for the surface area, we are going to get the area of all the surfaces that we can see. So as usual, we're going to begin with the rectangular part, which has how many faces are these? It has 1, 2, 3, 4, 5 faces. So I'll start with this face here. I'll start with this face. This face, the area of that face is 6 multiplied by 5. So 6 multiplied by 5. So 6 multiplied by 5, and then multiply by 2, because we have the other face on the other side. And then we have this face that is here. This one measures 10 by 5. 10 by 5. That is 10 by 5. 10 by 5, and then times 2 because of the other side, on the other side. So we're done with that. And then we have the bottom one, which is 10 by 6. The bottom one is 10 by 6. So what is remaining now? We go to the top part. For the top part, we have this rectangle here that measures 10 by 4. And then there are 2 on the other side, so 10 by 4. So we have 10 by 4, then multiply by 2 because we have the other face on the other side. And then what is remaining now? The rectangular surfaces. And for the rectangular surfaces, we have the area of the surfaces. We got the areas of the rectangular surfaces is 7.937. So we multiply that by 2 because there are 2. So these now will give the total surface area. So we're getting the areas of all the surfaces. So these will be 30, these will be 60, plus these will be 50 times 2, these will be 100, these will be 60, these will be 80, these 40, these will be 80. Then for this one, 7.9, and try to multiply these, so 7.937 multiplied by 2, 15.874. 15.874. Now we can get the total. The total we have 60 plus 100 plus 60 plus 80 plus 15.874. So this gives a 315.874 centimeters squared. So that is the surface area. Now, part C, the block was melted and recast into a cone of height 18 centimeters. Determine the radius of the cone formed. So this block was melted and recast into a cone. So there's one thing that we can get from that. If it was melted, if this metallic block was melted and recast into a cone, then the volume of the cone will be equal to the volume of that block. The volumes will be the same if it was melted and recast into a cone. So that means the volume of this cone will be equal to the volume of this block. And since we have the volume of this block as 379, so it will be 379.37 centimeters cubed. Now we need to get the area or the volume of the cone. How do we get the volume of the cone? We get it by not 2/3, but it is given by 1/3 pi r squared height. So we have 379.37, which is the volume of that cone, which is similar to the volume of the block, is equals to 1/3 times 22/7. We're using the pi, so 22/7 times the radius. We don't know the radius, so the radius squared, then times the height, which is 18. So what we need to do is just to make r the subject. So make r squared the subject of the formula, and r squared will be 379.37 multiplied by 3 multiplied by 7, everything divided by 22 times 18. So this one, r squared, will be given by, so this will be 379.37 times 21, that is 3 times 7, and then everything divided by 22 times 18. So you get r squared is equals to 20.12. So radius, that is radius squared, is equals to, so radius squared is equals to 20.12, correct for significant figures. So to get the radius, you get the square root of both sides. So the square root of 20.12, that will be 4.4866. centimeters. So that is the radius of this cone.